can just double click and type construct domain. So let's enter a domain of numbers or a range of numbers. Anything will do. You can also input a range and see what happens. A domain of numbers will also work in this case. You can just input this. And let's change the domain. Let's give it a higher domain. Let's make the domain start to somewhere around 8, and let's keep the domain end to somewhere around 55. Let's input all of these things. Now you see you actually have some control over the geometry. Now that you have done all of these things, you can control all of these geometries, as you can see. And as you see, as I go ahead and increase and decrease these things, they actually react in a very particular way. So in order to understand what is actually happening, let's go ahead and turn everything else off except for this Metaball component. So I'll go ahead and turn everything else off. I'll select everything, use my central mouse click and turn it off. Now you can actually see what is happening. So let's understand the full script in action, and let's understand what is actually happening. So the Metaball custom component, it creates these kinds of Metaballs by taking in custom charge values. So the charges that you are inputting right now, let's enter a panel component and understand what charges are being inputted. I'll just enter a panel component, attach it to random, and I'll understand these are the charges. So I have 0 to 9, which means I have 10 charges because I have only 10 points. And these are my charges. So these are the values. So based on the size of the values, the size of the sphere is accordingly created. Let's understand the next thing, which is these planes. Now, since we are creating random numbers, we are creating a random numbers from the domain of 10 and 96. So all these numbers that you can see are random numbers selected from 10 to 96. So you have a lot of numbers till 94. So you have random numbers from 10 to 96, and in this domain, these curves are actually seen clearly based on what size you have. So if I increase and decrease the size, the shape and the form of this curve will change. So Metaball very clearly depends on what kind of a size of geometry are you using for it. If it is according to scale, then all of these things will actually change accordingly. So if I increase or decrease these things, they react accordingly. So if I just change the maximum value of this to 100, and now I can actually go ahead and play around with my geometry in this particular manner. So as you can see, this entire thing is controllable. I can completely play around with this, and they join together like a blob, and there you go. So that's the basics of Metaball for you. So now that we have understood this, let's go ahead and delete this panel first. Now let's go ahead and give this thing some thickness and some 3D form. So we can actually convert all of these curves into surfaces first. You can always play around with this before you attach anything else to the script, because now whatever else we are going to do in this part of the script, it's going to make this really heavy. So make sure you are happy with whatever form you have attained till now. You can also play around with this right here. You change it to 0, nothing happens. If you change it to 2 and 3, 4 and so on, you see how the the distance between these curves change. You can also double click and change it to real numbers, so that, and you can also change the maximum to maybe 1 instead of 50. Now you can actually play around with the degree, you see. So if you create a really low degree of gaps between each of the curves, something like this, then you make sure that your distance is high enough. You do something like this, only and only then you can actually see all the curves. If you want a little bit of more gaps between the curves, then you can actually go ahead and increase it, but make sure your count is adjusted accordingly. If your count is too low, then you cannot see all of the geometry together, which means the planes are actually decreasing. You can actually see it happening over here. If I turn this component on, you see that if I decrease the count, I decrease my planes, and with my planes, all the curves also go away. I cannot see the curves. If there are no planes, there are no curves. So I'll just switch this off. So I think this is pretty good. Increase it a little bit more so that I have clean geometry. I think 1 is pretty good. So after you're happy with your geometry, you can turn all of these into surfaces. So you can double click and type boundary surface. Bring in this particular component which says boundary surfaces. Attach it to all your ISO curves, and you can wait for a little while because it might take a little while in your machine, if it's a very naive machine, to actually convert this thing into surfaces. If it's a fast machine, it will actually be fast, and you might also see that it will give you this error which says planar surface routine returned no results. This thing is just in case, because after this thing is completed, there are very minute other curves that are not visible to us right now on this viewport, which might not have been converted into some of these surfaces. There might be 1 or 2 curves, so that's why it's returning this kind of a result, and your component is yellow instead of white. So we don't need to worry about that. We can just go ahead and extrude now all of these into some 3D solids. So you can double click and type extrude, bring in the extrude component. You can give it a direction, just double click and type Z, bring in the unit Z component, attach it to direction. Let's give it a number slider to control the extrusion. You can just double click and type 0.50, bring in a number slider of 0.50, attach your surface to the base. This will actually create a 3D form in all these particular surfaces. It will actually take a little while in your case if your machine, if you're using a laptop, but if you're using a really high power desktop, then it might happen fast, just in my case like this. So if something like this happens, if you're using a desktop and the Grasshopper window just goes away, just minimize your desktop like this and then maximize it like this, and then your Grasshopper window will come back. So after you are done with this, you can actually see that we have created some 3D solids. Now let's give it some nice color. So I can just turn this component off now. I don't need the curves anymore, I have the solids. You can also turn the surfaces off. After you're done with all of these things, you can just double click and type custom preview. Bring in the custom preview component. You can attach a color swatch to it. Just double click and type swatch. You have the color swatch. Change its color to something like blue maybe. Click on accept and attach your extrusion to geometry. See, you have blue colored metaball. You can actually turn this off. Now you can actually go ahead and give it some kind of an outline. So we have a very nice component for that, which is known as brep wireframe. It extracts the wireframe and you can then give the wireframe some color. So let's double click and type brep wireframe. Of the brep wireframe, it extracts the wireframe curves of a brep. So we have the brep over here. You can plug this in brep and you see you have the wireframes, which are currently displayed by the red color. So let's change it to black. You can just copy both of these things by pressing Alt and attach this to geometry and change the color to black and click on accept. Now you see you have a very nice looking geometry. So let's go ahead and turn everything else off except for these 2 custom preview components. You can actually go to your rendered viewport if you are using Rhino 6 and you can find a very interesting geometry preview of what you have just done. What you can also do is, if you have something like this, you can change your color to maybe white and find even a better alternative of what you are looking for and click on accept. And if you want these particular curves to appear over here, you can just right click and click on bake. Click on layer 1 or layer 2 or whichever layer you wanted to bake it on. I'll just bake it on default and I'll group it. Click on OK. And all the curves, I guess, will be now visible, and there you go. You have all the curves visible over here with your rendered geometry. So you can always have this, or you can just click on Ctrl Z and always go back to your original setting. So this thing is in accordance with the Grasshopper geometry. We have not baked the result. This is the Grasshopper custom render preview, you can actually turn this entire thing off. So I'll just select this. Now make sure you don't make any changes in your script while all of these components are on. If you want to make changes, you have to turn this, you have to disable all of these components, and only then you can make the changes. Otherwise your script will hang because it's a really heavy script. So I'll just go ahead and select all of this, use my central click on disable all selected objects, which means all of these components will now stop functioning, and you see how they turn like this. So I'll just turn this on and I can see my lines now, and if I change it, if I play around with the seed, and if I have some other kind of a form which I actually like, say I like this particular form, so now I can just go ahead and enable all of the other things. I'll just turn this off first and I'll enable all of the other things. Click on enable, and it will take a little while it boots up and it loads up and it creates the surfaces and the solids, and until that happens, let's wait. And there you go. You see now we have a totally different form from the one that we had created before previously. So you can play around with this script, you can create interesting forms and interesting shapes for your design concepts and actually get some really interesting results. So that is it for this particular topic. In the next topic, let's explore a concept known as box morph in Grasshopper 3D.